So children, today's class we are going to discuss about the chemical properties of methane and ethane. That means the chemical properties of alkanes. Generally, we can call like that also. Children, there are certain chemical properties such as substitution reactions, oxidation reactions, etc. Before talking about those concepts, let me give you a general idea. Children, if you consider the chemical properties of methane and ethane, we know that methane and ethane are saturated hydrocarbons. I hope in the beginning classes already I discussed about saturated hydrocarbons, right? So I think you guys have those ideas. So listen carefully, children. Methane and ethane are saturated hydrocarbons. Because of this reason, they won't react with sodium hydroxide. So that means they do not react with bases. Understood? So the first point you should remember like this: methane and ethane are saturated hydrocarbons. So the first point, they do not react with bases such as sodium hydroxide. Second point, they do not react with oxidizing agents such as potassium permanganate. Third point, they won't react with reducing agents such as sodium metal. I hope you guys understood this. Children, we are talking about the chemical properties of methane and ethane. So please understand, methane and ethane are saturated hydrocarbons. Because of this reason, they won't react with the bases such as sodium hydroxide. They won't react with oxidizing agents such as potassium permanganate. Also, they won't react with reducing agents such as sodium metal. I hope you understood this. Now, children, we are going to talk about the substitution reaction. So we know that alkanes will react with the chlorine, bromine, or iodine in the presence of sunlight or ultraviolet, and it will give halogen substituted products. And this halogen substituted products, we call it as alkyl halides. Listen carefully, children. We are going to talk about first chemical properties of methane and ethane. That is nothing but substitution reaction. What do you mean by substitution reaction? I'm going to explain. Children, we know that alkanes will react with the chlorine, bromine, or iodine in the presence of sunlight or ultraviolet rays, or the temperature is above 600 Kelvin, and it will give halogen substituted products. These halogen substituted products are known as alkyl halides. Understood? Now, children, let me explain by using an example. So you just consider methane. This methane is react with chlorine in diffuse sunlight, or when it heated to 600 Kelvin, what happens? Children, listen carefully. When methane reacts with the chlorine in diffuse sunlight, or the temperature is above 600 degrees Celsius, then you guys will get chloromethane. So please listen to this reaction. CH4 methane plus chlorine Cl2 reacting at the presence of sunlight or 600 Kelvin will give chloromethane CH3Cl plus HCl. And that diagram already given here. So this is the diagram. So children, see, this is nothing but CH4. This is nothing but CH4, right? And this one is nothing but Cl2. So what happened? One hydrogen is substituted by using one chlorine. One hydrogen atom is substituted by using one chlorine atom. So hence finally you guys will get chloromethane. So children, listen carefully. In this reaction, chloroethane CH3Cl is found by the substitution of hydrogen atom of a methane molecule, right? So this hydrogen is substituted by a chlorine atom, right? So by this you guys got chloromethane. Hence this reaction is known as substitution reaction. Any doubts? Is it okay? Once again, I'll explain, children. Listen carefully. We are going to talk about substitution reaction. Here, alkanes react with chlorine, bromine, and iodine. So this reaction will happen in the presence of sunlight or ultraviolet, or the temperature about 300 Kelvin. Now, children, in order to explain this, I'm going to introduce one example that is nothing but methane will react with chlorine in the presence of sunlight or the temperature is 600 Kelvin. Then what happened? One hydrogen atom one hydrogen atom of methane is substituted by one chlorine atom, and you got chloromethane. And this process we call it as substitution reaction. Hope everyone understood this. Now we'll do more examples, children. Listen carefully. Next example. Second one, we'll take CH3Cl. Into that, we are introducing Cl2. Then what happened? You guys will get CH2Cl2 plus HCl. So how is this possible, children? Listen carefully. CH3Cl means this is nothing but carbon. Here you have hydrogen. Here also hydrogen. Here also hydrogen. Here you will have one Cl plus Cl. This will give what happens, children? This Cl will go to here. Understood? And this hydrogen will go here. Okay. So you guys will get this as carbon, hydrogen. Sorry, that is substituted, right? Carbon. This is Cl. This is also Cl. Here it will be hydrogen. Here it will be hydrogen. Plus, you guys will get this H and the Cl. So finally, you guys will get it as CH3 Cl plus Cl2 will give CH2 Cl2 plus HCl. I hope everyone understood the substitution reaction. Is it okay? Albina, is it okay? So this one, we call it as monochloromethane. This is our second reaction, monochloromethane. And you guys got dichloromethane. You guys got dichloromethane. Now, children, just write this. Now, children, just take this dichloromethane. Just select the dichloromethane. That is nothing but CH2, Cl2, right? Plus Cl2. You guys will get it as one more hydrogen is substituted, right? CHCl3 plus HCl, you guys will get. Please draw and check. You guys will get it perfectly. This is nothing but dichloromethane. This is dichloromethane. And finally, you guys got the product as trichloromethane. This trichloromethane is generally known as chloroform. In movies and all you heard, right? Chloroform. This is nothing but trichloromethane. Now, fourth reaction, children. You take this trichloromethane, CH3, Cl2 plus Cl2. You guys will get it as CCl4. The last hydrogen will substituted, and you guys will get C5. HCl is the byproduct. So this one we call it as trichloromethane. Trichloromethane. Finally, CCl4, tetrachloromethane. Right? So this reactions we call it as substitution reaction, because all of this reaction you understood, one hydrogen is substituted by chlorine and you guys are getting the products. I hope you guys understood. Now children, listen carefully. We are going to do the substitution reaction of ethane, that is nothing but C2H6. So C2H6, the same method what you applied for methane, the same trick you can apply here also. One hydrogen you can substitute with chlorine. Okay, so first example I took C2H6 ethane and chlorine. So you guys will get it as C2H5Cl. That means one hydrogen is substituted by chlorine. Now select C2H5HCl. That is nothing but monochloroethane. C2H5Cl. Substitute one chlorine into that. Then you guys will get it as dichloroethane. Similarly, children, you can find trichloroethane, tetrachloroethane, pentachloroethane, and hexachloroethane. Just substitute one hydrogen with chlorine and write the products. Understood? So please do that. This is a homework. So children, listen carefully. Now we are going to talk about the second chemical properties of methane and ethane. That is nothing but oxidation reaction. This oxidation reaction, generally we call it as reaction with oxygen. So when methane react with oxygen, you guys will get water and carbon dioxide as a product. Ethane when react with oxygen, then also you'll get carbon dioxide and water. So children, in the presence of air or oxygen, methane or ethane burns with a non-luminous flame. This non-luminous flame, generally we call it as bluish non-sooty flame. Understood? And you guys will get a product, water and carbon dioxide. So in the presence of air or oxygen, methane or ethane will burn with a blue non-luminous flame. This blue non-luminous flame, children, they can ask in other term also, that is nothing but bluish non-sooty flame. That's why I wrote two flame names. Okay, so the products are nothing but, you understood, that is nothing but water and carbon dioxide. So this is for today, children. So next class I'll start with alkenes. Thank you, children. Have a nice day. Bye.
Thank you, sir.